Today in this video we will discuss about friction, what is meant by friction and which are the types of friction, all those things we will discuss in detail in this video. Okay. So first of all we will discuss what is meant by friction. Friction is the force which comes into play whenever a body moves over the surface of another body or tries to move. The opposing force will be acting, and that opposing force is known as friction. Okay. So friction means the opposing force which arises whenever an object moves or tries to move over another object. So it's not necessary that the object should be moving. If it tries to move over another surface also, there will be an opposing force. So that force is known as frictional force. Okay. And this frictional force is a contact force. So here if you are considering the surface is there, here this block, a block is there, and if our applied force is in this direction, we are applying force. So in which direction frictional force will be acting? Frictional force will oppose. So it will act in opposite direction to the applied force. So this will be the frictional force, and if applied force is in this direction, again we can say that this frictional force will be acting opposite direction. Okay. And this frictional force arises due to the intermolecular force of attraction between molecules and atoms, because of which this frictional force arises, because there will be irregularities on the surfaces. So whenever the object tries to move over another object, these forces will be acting. Okay. So we can conclude that frictional force will be always acting opposite to the direction of motion. And now we can say which are the types of friction that we will discuss. So first of all we will discuss what is meant by limiting friction, static friction and kinetic friction. Okay. So static friction. Static friction means it is the frictional force which acts on an object when the object is at rest. Okay. When the object is at rest but it tries to move. It is not moving but it tries to move. That case the friction acting is known as static friction. Okay. Static friction means it is the frictional force which acts on an object when the object is at rest. So even though the object is at rest, some external force is acting, because of which it tries to start its motion, but it is not moving. And that time the frictional force is known as static friction. Okay. Static friction means before the frictional force acts on an object, before the actual motion of the object starts. Okay. The frictional force acts on an object before the actual motion of the object starts. Before the actual motion of the object starts. Okay. That is known as static friction. So we will write it as Fs, static friction. And now we will discuss about limiting friction. Limiting friction. The maximum value of static friction is known as limiting friction. Okay. Limiting friction means the maximum value of static friction. The maximum value of static friction is known as limiting friction, and it is clear, no? And now we will discuss about kinetic friction. Kinetic friction, and it is also known as dynamic friction. Kinetic or dynamic friction. So, kinetic friction or dynamic friction means it is the frictional force which acts on an object when an object is moving over the surface of another object. So you may think that is it possible for frictional force is acting? No doubt at all, it will be acting. That's why you might have noticed that when a ball is moving over the surface, after some time that ball is coming to rest because of the frictional force acting on the ball. Okay. So kinetic friction means it is the frictional force which acts on an object when the object is actually moving over the surface of another object. Okay. The frictional force which acts on an object, on a body, when the body tries to move over the surface of another body. So the frictional force which acts on an object when the object actually moves over the surface of another body. And here static friction means it is not moving, it is at rest also. That case also, even though frictional force is acting, even though applied force is there, that applied force is not sufficient to overcome the frictional force. Okay, is it clear? So this is about static friction, limiting friction and kinetic friction. Now two more frictions you might have here. Sliding friction and rolling friction. Sliding friction means it is the frictional force which arises whenever an object slides over another object. Okay, the frictional force which arises whenever an object slides over another object. Whenever an object slides over another object, the opposing force arises is known as sliding friction. For example, if you are dragging by using a rope, if you are dragging something, or if you are pushing something, okay, that case sliding friction arises. Next is rolling friction. Rolling friction means it is the frictional force which arises whenever an object rolls over the surface of another object. The frictional force which arises whenever an object rolls the surface of another object. The frictional force which arises whenever the object tries to roll over the surface of another object, that time the frictional force arises is known as rolling friction, and rolling friction is less than sliding friction. Okay, that's why we know that wheels are made in the shape of circular in shape, no? Because of this, rolling friction is less than sliding friction. Okay, so clear? And now we will discuss about the graph between applied force and friction. Graph connecting applied force and friction. So we are applying force on an object, and what happens as we applied force, we are varying from 0 to some value. Okay, so as the applied force increases, the frictional force, static friction also gradually increases. Initially, if it is at rest, if no applied force means no frictional force. Once it tries to move over the surface, that time static friction arises. Okay. So as the applied force increases, we can say that the static friction also increases, and a stage is reached when the applied force, we can say that the applied force is directly proportional to that, static friction is directly proportional to applied force, and then it reaches the peak value. That peak value is known as limiting friction, and once it started its motion, then it changes to kinetic friction. Okay, so if we are plotting a graph, we can see that this is applied force and frictional force. We are plotting a graph between applied force and frictional force. We told you as the applied force increases, it starts from 0, and as the applied force increases, frictional force also increases. It is a linear curve. So this part corresponds to static friction. And next what happens? It reaches a maximum value. Once it reaches a maximum value, then it decreases and the object starts its motion, then it changes to, it becomes constant value, and that is known as kinetic friction. So this part we can say that static friction. Here the maximum value, we can say that limiting friction. So this maximum value, we can say that limiting friction. Up to this point, we can say it will be static friction, the object will be at rest. Maximum value. Then what happens? It decreases and the object starts its motion. That time it will be the kinetic friction. So we can say kinetic friction will be less than the limiting friction. Once the object starts its motion, the limiting friction is changed into kinetic friction. So kinetic friction will be less than the limiting friction, and it is a constant value, you can say. It's not like static friction, but kinetic friction is a constant value for a given surface. Okay, is it clear? This is the graph between applied force and frictional force, and now we will discuss the laws of limiting friction. Okay, laws of limiting friction. Laws of limiting friction. So there are 4 laws. So first law, what it is? The limiting friction depends on the nature of surface nature of surface and state of force. The limiting friction depends on the nature of surface and state of polish. How much smooth is the surface, whether the surface is smooth or surface is rough, accordingly limiting friction will change. If the surface is too much rough, limiting friction will be more, and if the surface is highly polished, very smooth surface, limiting friction will be less. That's why we can say limiting friction depends on the nature of surface and state of polish, whether the surface is polished or whether the surface is very smooth or rough, accordingly limiting friction will be changing. Limiting friction will be more if the surface is rough and it will be less if the surface is smooth. That is first law. And second law, the limiting friction acts tangential to the surface and in a direction opposite to the direction of apply. Opposite to the direction of motion. The second law says that limiting friction acts tangential. What is meant by tangential? Through the tangent. So, if our object is there and this is the surface, and in a direction opposite to the direction of motion. Opposite to the direction of motion means opposite to the direction of applied force. So here I told you, if our applied force is in this direction, the limiting friction will be acting tangentially. If this is the surface, the tangent will be acting in this direction. So here it will be acting tangent we can go in this direction also, but it is given that in a direction opposite to the direction of motion. Okay, so it will be acting in this direction. So this is, so limiting friction we are writing it as Fs max. Why we are writing it as Fs max? It is the maximum value of static friction. That's why we are writing Fs max. Okay. So second law says that limiting friction is acting opposite to the direction of motion and acts in a tangential direction. Okay. And third law, what we can write? Third law we can write like this. The limiting friction does not depend on area of contact. As long as the normal reaction remains same. The limiting friction does not depend on the area of contact. So you may think that depends on the area of contact, but it does not depend on the area of contact. One condition is that provided the normal reaction remains same. As long as the normal reaction remains same, we can say that limiting friction does not depend on the area of contact. Okay, limiting friction does not depend on the area of contact, provided normal reaction should remain same. Okay. Now the last one, the limiting friction is directly proportional to the normal range. Limiting friction is directly proportional to the normal range. Okay, so here you can see that an object is there. This over the surface of another object. Our applied force, for example, is in this direction, and static friction will be acting in this direction. What it says, limiting friction is directly proportional to normal reaction. Normal reaction will be acting normal to the surface. So if we are writing normal reaction as R, we can write, and this will be W will be acting downward direction. So we can write limiting friction. What it says, limiting friction is directly proportional to normal reaction. Okay, limiting friction is directly proportional to normal reaction, or we can say that limiting friction is equal to a constant into normal reaction. This is mu s, and it is known as mu s is the coefficient of static friction. Mu s is the coefficient of static friction. So we can say that Fs max is equal to mu s into R, where mu s is constant for given surface. It will be given in the problem. Whenever you have to calculate, it will be given in the problem. Or they may give Fs max and R, you have to find these. These are experimental observations. Okay. From experiments or from practical observations only, they concluded this rules. Okay. So we can say that limiting friction is directly proportional to normal reaction, or limiting friction is equal to a constant into normal reaction, and that constant is known as coefficient of static friction. That's why we are telling from in this expression, in this third law, what it is written, limiting friction does not depend on the area of contact, provided normal reaction should remain same. If normal reaction changes, limiting friction also changes. Okay, and now we will discuss about the laws of kinetic friction. Okay, laws of kinetic friction. The first one, the kinetic friction opposes the direction or acts in a direction opposite to the direction of motion. Acts in a direction opposite to the direction of motion. And has a constant value which depends on the nature of the surface. Here also we can say that it acts in a direction opposite to the direction of motion, and it has a constant value. Kinetic friction, in that graph also you might have seen. We are getting a constant kinetic friction for a given surface. Okay, it depends on the nature of surface. And second law says that the kinetic friction does not depend on area of contact, provided the normal reaction remains. Normal reaction remains same. The kinetic friction, similar to static limiting friction, we can say that does not depend on the area of contact, but one condition is that normal reaction should remain same. Okay, and third one we can write the kinetic friction does not depend on the velocity of the object, provided the velocity should not be too low and too high. Okay. Provided the velocity is neither too small or neither too small nor too large. So it does not depend on the velocity. One condition is that velocity should not be very small, or if the velocity should not be very large. If the velocity is very small and if the velocity is very large, kinetic friction depends on velocity. Otherwise, we can say that kinetic friction does not depend on the velocity of the object unless velocity is very small or very large. Okay. And last one, the kinetic friction is directly proportional to normal. Kinetic friction is directly proportional to normal reaction. Okay. So here we can write Fk. We are writing kinetic friction for Fk. So Fk is directly proportional to R, where Fk is kinetic friction and R is normal reaction. Or we can write Fk is equal to mu k into R, where mu k is known as, what is mu k? Mu k is the coefficient of kinetic friction. Mu k is the coefficient of kinetic friction, depends on the surface. Okay, and we can say that mu k is less than mu s. Mu k will be always less than mu s. So we can say that kinetic friction is always less than, kinetic friction is always less than limiting friction. Okay, is it clear? And now we will discuss about angle of friction. Angle of friction. So what is meant by angle of friction? Okay. So before defining what is meant by angle of friction, we'll see the case an object lies over the surface. Okay. Angle of friction we are defining. So applied force is in this direction. Limiting friction is in this direction, or static friction, whatever it is. Limiting friction is acting in this direction, weight is acting vertically downwards, and normal reaction so if we are finding the resultant of normal reaction and Fs max, which direction it will be there? We can draw here. This is Fs max. So it may for example, if it is in this direction, we can draw a parallelogram and we can find the resultant. Then it is rectangle only. So this is the resultant of Fs max and Rs. So this resultant is making an angle with normal reaction, and that angle is known as angle of friction. Okay. So can we define angle of friction? Angle of friction is the angle made by the resultant of normal reaction and limiting friction with normal reaction. Okay. The angle made by the resultant of the angle made by the resultant. This is a resultant of what? Resultant of normal reaction and limiting friction. Normal reaction and limiting friction with, so this is the case, what is the resultant? Resultant of what? Resultant of limiting friction and normal reaction. That makes an angle with the normal reaction. With normal reaction. The angle made by the resultant of normal reaction and limiting friction with normal reaction, that angle is known as angle of friction. Okay, is it clear? And angle of friction is the angle made by the resultant of normal reaction and limiting friction with normal reaction. Okay, so we can find an expression for this angle. So if we have consider the triangle OA. So from the triangle OBC, we can write tan theta is equal to BC by OB. Tan theta is equal to BC by OB, and BC can be written as OA. So OA by OB. And what is OA? OA is equal to Fs max. Fs max by OB. What is OB? OB is equal to so tan theta is equal to Fs max by R, or already we know that Fs max is equal to mu s into R, or mu s is equal to Fs max by R. So here we can, instead of this we can write mu s. So mu s is equal to tan theta, or mu s is equal to Fs max by R, or tan theta is equal to Fs max by R. Okay, so this is the relation connecting coefficient of static friction. So the coefficient of static friction and angle of friction. I hope all of you understood. So today we discussed about what is meant by static friction, kinetic friction, limiting friction, rolling friction, and laws of static and kinetic friction and angle of friction. I hope all of you understood. Thank you.